So continuing the January 2021 paper. The diagram below is where question 6, of course. So there's a rectangular tank with base 50 centimeters by 40 centimeters, and there's a height of water. The height of water in the tank is 15 centimeters. So now we have to calculate the volume of water in the tank, and the volume of water is length times breadth times height. So it's 40 times 50 times 15. The length is actually 50. Breadth 40, but it doesn't matter. 50 times 40, 40 times 50 is the same value. So the volume is actually, let's see, so $30,000 centimeters cubed. Next. So we have the cylindrical container shown in the diagram below is used to fetch more water to fill the rectangular tank. The container, which is completely filled with water, had a radius of 20 centimeters, as we can see here, and a height of 21 centimeters. All the water in this container is added to the water in the rectangular tank. Calculate the total volume of water that is now in the rectangular tank. So let us first calculate the volume of the water in the cylinder. The volume of the water in the cylinder will be pi r square. Volume of cylinder is pi r square times height. So volume, let's use pi as 22 over 7. The radius is 20, so 20 square times the height, and the height is 21. Let's calculate that now. So 22 over 7 times 20 square times 21. So that's 26,400 centimeter cubed. Alright, so the total volume of water in the rectangular tank now. So total volume of water in the rectangular tank now, you will recall in the rectangular tank we had, what was the value again? The value in the rectangular tank was, gone too far, was 30,000 cm cubed. So now it would be 30,000 plus 26,400. So the total volume of the water in the tank now, the rectangular tank, would be 30 plus 26, that's 56,400 centimeter cubed. Next, we are asked to show that the new depth of the water in the rectangular tank is 28.2 centimeters. So, remember, volume of water in the rectangular tank, LEH, the volume is 56,400. Volume now, 56,400. The length and the breadth was 40 by 50. Alright, so we want to find the height. 40 by 50, that's what, 2,000. 56,400. So of course, to get the height, we can divide both sides by 2,000. So the height, the new height, is now 56,400 divided by 2,000, which is 28.2 centimeters. The vertical height of the rectangular tank is 48 centimeters. Determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. So now if the height is now 48, the volume of water would be 40 times 50 times the height, 48. Now what's 40 times 50 times 48? 40 times 50. times 48. That's 96,000 cm cube. You'll remember that the volume of the, and this is volume for rectangular tank, right? Let me put rectangular tank. And let's do the volume for the cylindrical tank. We did that calculation already. Just remind ourselves of what that was. The cylindrical tank. Its volume was, what was it again? The cylindrical tank. The volume was 26,400. So this is the capacity, the full capacity of the rectangular tank, 96,000. But remember, we already have 56,400 in the rectangular tank. Alright? The rectangular tank already has, so the rectangular tank already has this tank. Rectangular tank already has 56,400 centimeters cubed in it, right? So which means that so it can hold, so the rectangular tank can hold 96,000 minus 56,400. It can hold 39,600 centimeter cube more. Because this is the amount in it, alright, and this is the amount, this is the capacity. This is the maximum it can hold, 96,000, and it already has 56,400. So to be completely filled, it needs 39,600 more, 39,600 cm cube more of the water. Alright, and the cylindrical tank can hold 26,400. Alright, so the number of tanks, number of cylindrical tanks needed to fill the rectangular tank will be now equal to 39,600. That's the amount of water you want, divided by 26,400. And what's 39,600 divided by 26,400? 1.5. So to fill up the rectangular tank, we need 1.5 more, or 1.5 more of the cylindrical tank. So now we are at question 7. The diagrams below show a sequence of figures made up of circles with dots. Each figure has one dot at the center, 4 dots at the circumference of each circle. The radius of the first circle is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous circle, except for the first figure. A portion of each of the other figures is shaded. Complete the rows in the table below for figure 5 and the figure N. Alright, so there's our table. And we are asked to complete the table. Let us see if we can pick up the general pattern here. The pattern I'm seeing between the number of figure and the number of dots. Yes, the pattern I'm seeing here between the number of figure and the number of dots. Notice when you multiply the number of figure by 4 and add 1, you get the number of dots. So 4 times 1 plus 1 give you 5. 4 times 2 plus 1 give you 9. 4 times 3 plus 1 give you 13. 4 times 4 plus 1 give you 17. 4 times 5 plus 1 give us 21. So relationship between number of figure and number of dots, that's 4n. So the number of figure multiply by 4, and then we add 1. That's how we get the number of dots. Okay, alright. Let's deal with the number of the figure number and the area of area of the larger circle. Alright, notice. So 1, 1, 2, 2 square, 3, 3 square, 4, 4 square, 5, 5 square, n, n square. So this will be n square times pi. Alright, let's see if we can figure out. Notice, so this one, notice the pattern I'm picking up between the figure number and the second to last column. So 2 times 2 take away 1, we get 3. 2 times 3 take away 1, we get 5. 2 times 4 take away 1, we get 7. 2 times 5 take away 1, we get 9. So this should be 9 pi. Notice the number of pi increasing by 2. Another way to look at it. Alright, and so this would be 2 times n. So multiply the number of figure by 2. And then we subtract 1, right? So 2n minus 1 pi. And for the final column, the pattern I'm picking up, notice the pattern I'm picking up. So to get between the figure number and the final column here. So is 1 times the number, the next number, which would be 2, or 1 times 2, this, 2 times 3, that's how I get the 6, 3 times 4, that's how I get the 12, 4 times 5, that's how I get the 20. So this 5 times 6, that would be 30. So this would be 30 pi. So notice to get the value over here, it's n, whatever the figure number is, times the number that follows n. Times pi. This one, not so easy to see. So 1 times the number that follows 1, which will be 2. So 1 times 2, 2. 2 times the number that comes next, so which will be 3. So 2 times 3, and so on. 4 times the number that comes after 4, that's 5. So 4 times 5, that's 20. 3 times 4, 12, and so on. So the number that follows 5 is 6. 5 times 6, 30. The number that follows n is n plus 1. So it's n times n plus 1. Next, we're asked to determine the value of n when the number of dots in figure n is 541. Determine the value of n when the number of dots is 541. So let me go back up to the table here. Oh no, I'm too far. So when the number of dots, when the number of dots is, notice the number of dots is 4n plus 1. Alright, 4n plus 1 in the n row. So when the number of dots, equal to 4n is equal to 4n plus 1. Alright, but the number of dots, we are told the number of dots is 541. So 4n plus 1 equal to 541, right? Subtract 1 from both sides. So 4n equal to 540. Divide both sides by 4. So 4 into itself, that's 1. So 1n, which is just n. So 540 divided by 4. 4 into 5, that's 1. 1. 4 into 14, that's 3. Remainder 2. 4 into 20, that's 5. So the value of n, when the number of dots is 541, the value of n would be 135. Write down in terms of p and pi the area of the largest circle in 3p. In figure 3p. Let's look at figure 3p. Now, the area of a larger circle is always n squared times pi. The area of a larger circle is n squared times pi. This, alright? Just, So the area of a larger circle is n squared times pi. But we're asked for a figure 3p. Alright, so n would be 3p. N is a figure. So n is 3p. So replace n with 3p. Alright. So n squared times pi. So it's 3p squared times pi. So the area of a larger circle in figure 3p. 3p squared, that's 9p squared times pi. So now we are on to question 8 in section 2. The straight line graph of x equal 5 minus 3y intersects the x-axis at P and the y-axis at Q. Determine the coordinates of P and Q. Alright, so graph cuts x-axis when y equal to 0. So here's a function graph. We set y is equal to 0, so we have x equal to 5 minus 0. Since y is 0, then 3y will be 0. So coordinates of P. So coordinates of P would be x is 5 and of course y is 0. Graph so P 5 0, right? So graph cuts y-axis when x is 0. When x is 0, here, replace x with 0, so we have 0 equal to 5 minus 3y, and then we can solve. If 0 equal to 5 minus 3y, then 3y is equal to 5. And to get the y, we can divide both sides by 3. So y is 5/3. So y is 5/3, and that's what the coordinates of Q, right? So y is 5/3. And x is 0. So those are the coordinates of P and Q. Next, we're asked to calculate the length of PQ given your answer correct to 2 decimal places. So the length of PQ is equal to the square root of y1 minus y2 square plus x1 minus x2 square. So we can call this point, x1 and y1, and then this other point x2 and y2, right? The formula for length of a line. So y1 minus y2 will be 0 minus 5 over 3 square plus x1 minus x2, 5 minus 0 square. So you square root. Now 0 minus 5 over 3, that's negative 5 over 3. You square that, you get 25 upon 9. So it doesn't matter if it's x1 minus x2, if it's y1 minus y2, or if you have y2 minus y1. You square it, the value is still positive, so it doesn't matter. Likewise, it doesn't matter if it's 5 minus 0 or 0 minus 5, whether it's negative 5 or positive 5, you square, you get 25. Right, so this is the square root of 25 over 9 plus 25. So 25 over 9 plus 25, what's that equal to? That's 27.778. And the square root to 2 decimal places, that's 5.27 units. Now remember, P was 5, 0, and Q was 0, 5 over 3. We are told that R is a midpoint. R is a midpoint of PQ. Determine the coordinates of R. So the coordinates of R, so R is a midpoint. So the midpoint, remember the formula for midpoint, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So remember the x coordinates. What are the x coordinates? 5 and 0. Alright. Add the x values, so add 5. So 5 plus 0 divided by 2. And what are the y coordinates? 0 and 5 over 3 divided by 2. So R would be equal to 5 over 2, or 2.5. And 5 over 3 divided by 2, that's what? 5 over 6. That's 5 over 6. So that's the midpoint of R. 5 over 2 for the y-axis, for x coordinate, and y coordinate 5 over 6. So next we have part B. We have two functions f and g. F of x is 5 minus x. G of x is x squared minus 2x minus 1. The graphs of f of x and g of x meet at the point M and N. Determine the coordinates of the points M and N. So remember we have y, one of the functions f of x, let's call it y, is 5 minus x. And the other function y is x squared minus 2x minus 1. So to get the point of intersection, we can solve simultaneously. Alright, notice both y equal to 5 minus x and the same thing here. So therefore we can equate. So I mean x squared minus 2x minus 1. And we're using substitution here now. X squared minus 2x minus 1. All of this, we are told, is equal to y. And y is also equal to 5 minus x. So since this is equal to y, we can also equate it to 5 minus x. So both of them are equal to y. Both terms on the right hand side are equal to y. Hence both terms are equal to each other. For example, if I say to10 is equal to 6 plus 4, and I say 10 is also equal to 8 plus 2, then I can conclude logically that 8 plus 2 is equal to 6 plus 4. Alright, so there's a logic there. So in the same way, this what a circle is equal to y. 5 minus x is also equal to y. Hence, they must be equal to each other. Now we're going to solve now. So we have a quadratic, so we group everything on one side. So we have x squared minus 2x. I'm going to group with this negative x here, so I get positive x. I have minus 1. I'm going to group with this 5. I get minus 5 equal to 0. So I have x squared minus 2x plus 1x, that's minus x. And minus 1 minus 5, that's minus 6, equal to 0. And of course, now we can solve by factorization, or we can use the quadratic formula. Alright, whichever method you want to use. Let me use factorization method. So this is 1x squared, it's 1x. So AC, you're using the AC method. AC would be 1 times minus 6, that's minus 6. So I write down all the values that multiply to give 6, that's 1 and 6. And 2 times 3 also give us 6, right? So which pair either add or subtract to give you minus 1? Determine the middle. Of course, it's 2 minus 3. 2 minus 3 equals negative 1, the middle term. And when you take the product of 2 times minus 3, we get AC, which is negative 6. Which means that x squared and this negative 1 now can be rewritten as positive 2x minus 3x. So we rewrite the middle term, and then of course we have our minus 6. And of course we can factor by groups. The first pair, factor x, I'll have x plus 2. The second pair, the common factor there is minus 3. And of course, x plus 2. So common bracket is x plus 2. Outside we have x minus 3. So we equate both brackets to 0. So therefore x plus 2 is equal to 0, or x minus 3 is equal to 0. If x plus 2 is equal to 0, then x is equal to negative 2. And if x minus 3 is equal to 0, x is equal to 3. Let's find the corresponding y values now. Let's find the corresponding y values now. Let's make some space here. Up here now. When x is equal to 2, when x is equal to minus 2, let me do minus 2 first. Y is equal to, now remember what y was. Y, we have two values for y, two functions for y. It's up to you. You could use it, the quadratic one, or you could use the linear one, which is a 5 minus x. I'll be using the simpler one, 5 minus x. So if x is minus 2, then y is 5 minus, and then we put the value of x, which is minus 2. So the double negative, so y is 7. So when x is minus 2, y is 7. When x is, what's the other value? Positive 3. When x is positive 3, y is, again remember y is 5 minus x. So y would be 5 minus x, which is 3. So y would be 2. Alright, so we have our 2 points of intersection now, m and n. So the points of intersection would be, so therefore, coordinates of m and n are, and what are the coordinates? Notice, when x is minus 2, y is 7. So minus 2, 7. And when x is positive 3, y is positive 2. So the coordinates for the points of intersection, minus 2, 7, and the positive 3, positive 2. Part C, Monty is cycling 12 meters per second. After 4.5 seconds, he starts to decelerate. And we can see here, so he's cycling at 12 meters per second as we've seen in the graph, constantly. And after 4.5 seconds, there is a 4.5 there, he starts to decelerate. And after a further 2.5 seconds, he then stops. And we can see all of that in the speed time graph below. Alright, what are we asked to calculate now? So we're asked to calculate the deceleration. So deceleration is actually the change in speed. So change in speed upon the time taken, right? Or is a change in time. Notice the speed. Here, this initial speed here was what, 12? And then it went to 0. And the time taken, notice the time here. What's the time here? This is what, 4.5? And what's the time here? 7? Right, so it's 7 minus, this is the time here. The time, right? 4.5 and stop at 7. So it's 4.5. 7 minus 4.5. That's the time taken, right? So that's 12. And 7 minus 4.5, that's what? 2.5. So 12 divided by 2.5, that's 4.8 meters per second square. Next, we are asked to calculate Monty's average speed over the entire 7 seconds. Now, average speed is equal to total distance covered over the total time taken, alright? Over the total time. Now, how do we get the total? Now, total distance covered, we can find the area of the graph. Area under the graph. And the time, one of the time taken was 7 seconds. Let's go to the total distance covered. The total distance covered, we can find it using the area of the graph. Now notice the area of the graph here. Notice the area of the graph. So a break it up is actually a triangle and a rectangle. So it's a trapezium. So we have a triangle on the right and a rectangle on the right. So notice the area, the length and the width of the triangle here. The triangle here, this side is what, 4.5, 0 to 4.5, and here is what, 12. So it's 12 times 4.5. That gives us the area of the rectangular part. Let me just, so it's 12 times 4.5. What's 12 times 4.5? Times 4.5, so that's 54. And the area of the triangular part, now of course the height of this triangle is what, 12, just 12 is just the same. And the base of this triangle would be what? From 4.5 to 7.5. That's what, 2.5? It's 2.5, right? So the area of that triangle is 12, half base times height. So it's half of the base. So it's 0.5 times 2.5 times the height, which is 12. And I'm getting 15. So the total area is actually 69. 54 plus 15. So here in the graph would be 54 plus 15 divided by 7. Right, so that's 69 divided by 7. That's 9 point, if I'm using 2 decimal places, that's 9.86. I'll talk about average speed, so it's meters per second. Rounded to 2 decimal places. Next, we move to question 10. Question 9, sorry. So we have a diagram here. So it's a circle theorem problem. So we are also state the reason why angle ABC is 90. Which angle is ABC? Angle ABC, that's this angle. We are told angle ABC is 90. And what's the reason? As you can see, you notice AC represents the diameter. So angle ABC is 90. Because the angle is subtended from the endpoints of the diameter. And that's the reason. It's a circle theorem. Alright, notice the angle B subtended from the end of the endpoints, the endpoint of diameter here, and endpoints are A and C. So we subtend them to meet on the circumference. Alright, so that angle would have to be a 90-degree angle. Next, we're asked to determine, and with an explanation, the value of each of the following angles. So we want angle BAC, and of course we want the explanation or the reason. We also want angle, let me just make a note of all the angles. We also want angle Q, with an explanation of course as to why it has the value that it has. And we also want angle R, and we also want angle R. So we want angle BAC, angle Q, and angle R, with the reasons of course. Let me go back up to the shape, the circle. Now, if you look at triangle ABC, remember all the angles in a triangle add to give 180 degrees. So this angle 2P, this is angle BC, angle 2P plus 3P is plus this 90 degrees. So all the angles in triangle ABC, the sum should be 180. Now we can do some grouping here. 2p plus 3p, that's what, 5p. And then we can subtract 90 from both sides. So this is positive 90. So we subtract 90 from both sides, alright? So we have 5p. So 180 minus 90, that's 90. So we divide both sides by 5. So the value of p is 90 divided by 5. That's 18. So this angle BAC, so angle BAC is 2p, and of course p is 18, so it's 2 times 18, which is 36 degrees. Which means that this angle, so this is 36 degrees, let's put it here. And this is 3p, that's 3 times 18. Now also, notice BD is also the diameter of the circle here. Notice BD is the diameter of the circle. And we have angles subtended from the endpoints to meet at C. So this angle is a 90-degree angle. So 3p plus r is 90 degrees. Alright, and of course 3p, this angle we know 3p is 54. Remember p is 18, so 3 times 18, that's 54. Plus r is equal to 90. Subtract 54 from both sides. So r equal to 90 minus 54. So angle r would be 36. So this is 36 degrees. And of course, when you add these two angles, it must be 90, because notice angle B, notice for the endpoints of this diameter here, they meet at C here. So that's a right angle, as we can see. Now, last thing I want to find out is the value of Q. And of course, Q, notice what we have is an isosceles triangle here. Notice what we have here. This is the center of the circle. Alright, O is the center of the circle. Alright, notice the question tells us center O, so O is the center. So if O is the center, any line from the center to the circumference is a radius. So O to C is a radius. O to D is also the radius of the circle. So what we have is so ODC or OCD, whichever, is a isosceles triangle, which means the opposite angles are equal. Alright, so angle Q would be 36 degrees, and the reason triangle OCD is an isosceles triangle. From a harbor H, we have two buoys, S and Q, and we can see the angles there. So we have all the information there. We are told that, let's put in distances. We're asked on the diagram below, which shows a sketch of this information. Insert the value of the angle marked QHS. QHS, that's this angle. We are also told that, let's see what information, S and let's put in all the missing information here. The bearing from a harbor H of two buoys, S and Q. So S is 185 and Q is 311, as we are told. Alright. So which means that this angle would be 311 minus 185. That's 311 minus 185. This will be 126 degrees. Alright, we are also told that QH is 5.4 kilometers. 5.4 kilometers. And we are also told that S is 3.5 kilometers from H. So SH is 3.5 kilometers. SH, so this is 3.5 kilometers. And now we are asked to find the distance QS. So to get the distance QS, to get QS, of course, we can use the cosine rule. So applying the cosine rule, QS square is equal to 5.4 square plus 3.5 square minus 2 times 5.4 times 3.5 cos the angle between these two sides, which will be 126 degrees. And we'll use our calculator. In one step we can calculate that. So QS square is equal to 63.63, and which means QS will be the square root of 63.63. That's 7.98 alright, kilometers. If I'm using 2 decimal places. Next, we're asked to calculate the bearing of S from Q. The bearing, which angle is that? The bearing of S. Bearing of S from Q. So here is Q. We draw the north of Q. So we're coming from Q, which means we're coming from the north of Q to S. So we're talking about this angle. Alright? Now to get this angle, we certainly need to find angle Q. Alright? We certainly need to find this angle, so we can add it to this angle. So let's find angle HQS, this angle, before we can calculate the bearing. Now we can use the sine rule to get this angle. Let me call it Q. We can use the sine rule to get this angle. Alright, so we can say sine this angle, sine Q, upon the opposite side, which is 3.5, is equal to sine 126 over the opposite side, which is 7.98. Now we want the value of sine Q, so we multiplied both sides by 3.5. So sine Q would be equal to 3.5 times sine 126 upon 7.98, which means that sine Q, well, Q, we call it Q, which means that sine Q would be equal to 0.355, which means angle Q would be inverse sine 0.355, and our calculator can give us that answer. So angle Q would be equal to, so this angle is 20.79 degrees. Alright, so we know we want this angle. So the bearing, let's work out the angle now. So the bearing, the solution, the bearing of S from Q is equal to, now let me just break it up here. Now here to here, this is what east. Here to here is what, 90 plus, what's this angle? This angle is opposite, is alternate to this angle at H here. And angle H, what's angle H? Let's get angle H. To get angle H now, remember angles in a straight line had to give No, so from here to here, from north to this line here is 185. Alright? It's 185. But from here to here is 180. So this section will be 5 degrees. This will be 5 degrees. Alright? So this, so what? So 5 plus 126. That's what now? 5 plus 126. That's 131. That's 131. So this angle will be 49 degrees. Remember, all the angles must add to give 180. You know? So 126 plus 49. That's what? 175 plus this 5 to give 180. Alright, so now this angle is 49, which means this angle, it's a right angle, this is a right angle here. So this is 49, this angle here is a right angle. So this angle is 41 degrees. Alright, so if this is 41 degrees, alternate to this angle. So this angle is also 41 degrees. So here to here is north to the east, that's 90. And then this 41 plus this 20.79. So we have a total of 90 plus 41 plus 20.79. That would be equal to. So that's our solution. So given that W is equal to, this is 3, 6, minus 2, 5. Determine the 2 by 2 matrix L such that W plus L is equal to the 0 matrix. So so L, of course, if you add each element, you're supposed to get a 0 matrix. So L would simply be, alright, we simply can just change the signs. Notice 3 plus negative 3 give a 0. 6 plus negative 6 give a 0. Negative 2 plus 2, 0. 5 plus minus 5, 0. So L would be equal to that. Alright? Next we're asked for the 2 by 2 matrix P such that WP is equal to 1001. So WP is equal to 1001. So WP, what is W? Remember the matrix W was 3, 6 minus 2, 5. So 3, 6 minus 2, 5. That's what W was, right? Times P. Let me call P A, B, C, D. This matrix, and then let me just call it P. Times the matrix P, we're supposed to get the identity matrix. Now, which matrix multiplied, what do you multiply a matrix by to get the identity matrix? Right, you're correct. We multiply it. So what we need now is actually the inverse of this matrix. Let's find the inverse of this matrix. Alright? Alright, let me just do a different method. Many ways we can go about it. Let's find the inverse of this matrix here, P, of W. Now, this matrix, let's find the inverse. Alright, so P would be the inverse of this matrix. So P would of course be the inverse of this matrix. Because a matrix times its inverse would give you the identity matrix. So how do we find the inverse of a matrix? 1 over determinant times the adjoint. Now what's the determinant? Determinant, the cross multiply and subtract. So 5 times 3, 15. Take away minus 2 times 6. So take away minus 12. And the adjoint, switch diagonals, the leading diagonals. And then these elements change sign. So it's 6 and the positive 2. So the matrix P would be 1 upon 27. 5, 6, 2, 3. So the adjoint, so this would be negative 6, right? So this would be 5 upon 27, 6 upon 27, 2 upon 27, and 3 upon 27. So P would have to be equal to that, the inverse of W. So a right angled triangle M has vertices X, 1, 1, Y, 3, 1, Z, that's 3, 1, or that's 3, 4, Z, 3, 4. When M is transformed by the matrix N, and N is 0, 1, 1, 0, the image is M image. Find the coordinates of the vertices. So we're going to do them one by one. Alright, we'll do the X one by one. So X image is going to be 0, 1, 1, 0 times X, which is 1, 1. Let's calculate this now. So row by column, so 0, 1 times 1, 1. So 0 times 1, that's 0. Plus 1 times 1, that's 1. 1, 0 times 1, 1. So 1 times 1, that's 1. Plus 0 times 1, that's 0. So we have 1, 1. So the coordinates of X image is 1, 1. Y image, same matrix, 0, 1, 1, 0. 0, 1, 1, 0. Alright, we'll times that by 3, 1. Let me see. So we times this by 3, 1. So row by column, 0 times 3, that's 0. 1 times 1, that's 1. Then 1, 0 times 3, 1. So 1 times 3, that's 3. Plus 0 times 1, that's 0. So we are with 1, 3. So the coordinates here would be 1, 3. And then Z image, same matrix, 0, 1. We'll multiply to each vertex. So that's what now? Z is what? 3, 4. So multiply 0, 1 times 3, 4. So 0 times 3, 0 plus 1 times 4. So 0 plus 4. And then 1, 0 by 3, 4. So 1 times 3, that's 3. Plus 0 times 4, that's 0. So we end up with 4, 3. So 4, 3. And so X image, Y image, Z image is 1, 1, 1, 3, 4, 3 respectively. And thus a pointer information. Notice all the coordinates, the switch places. So really this matrix represents a reflection in the line Y equal X. If you notice what happened to each of the coordinates. Switch places. So we are on the final section, part C. So we have a vector. We have a triangle. There's OPQ. And OP, we are told OP is 3U. OQ is V. And Q is a midpoint of OR. And L is a point on OP. OL is 2/3 OP. A lot of information. Now we are asked to express in terms of U and V the vector LM. The vector LM. So LM, we can find LM. So LM would be L to P. So LM is equal to LP. Notice L to P. LM to get from L to M, right? L to P and then P to M. So LP, what is L to P now? Now LP, that's U, as we can see there, that's U, right? And PM is half of PQ. So maybe it's a good idea to find PQ first. Let's find PQ. PQ is PO. So P to Q, that's P to O plus OQ. So PQ, notice PO will be negative 3U. Direction change or sign change. So O to P is 3U, so PO will be negative 3U. And OQ, of course, is V. Alright, so PM PM, notice PM is half of PQ. Now we've seen that, because we're told that M is a midpoint of PQ. Alright, M is a midpoint of PQ. So PM is half of PQ. So PM, so is half of whatever we have for PQ, which is minus 3U plus V. So let's just simplify this. So this is become U expand. That's negative 3 over 2U plus half V. Alright, so group the U's. So what we have, so U minus 3 over 2U. So U, this is 2U upon 2, right? So it's minus U upon 2. Or minus a half U. Minus a half U plus half V. So LM minus a half U plus, write it better. Alright, so that's LM. Next we're asked to find the vector. Next we're asked to find the vector PR. So let's find the vector PR. Now the vector PR is PO plus OR. Now what is PO? PO, again PO would be minus 3U, opposite direction of OP. And OR, no, O to Q is V. Notice we're told that Q is at the midpoint. Q is the midpoint of OR. So OQ is V, Q is in the middle. So QR would be V also. So QR, of course, would be 2V. So PR is negative 3U plus 2V. And next, we're asked to prove that the points L, M, and R are collinear. Collinear means L, M, and R all lie on the same straight line. So I want to show that L, M, R all lie on the same straight line. Now we found LM, we found vector LM already. Now let us find the vector LR. Let's find the vector LR. We have LM, let's find LR. So LR, vector LR would be equal to LO plus OR. So LO, that's minus 2U. And OR is 2V. Now let's compare LR to LM and see if they are parallel. Notice LR, so it's LR. Notice, let me just factor LR. I can factor out 2. So this would be minus U plus V. Let me look at LM again. I factor out U. I factor out half. I end up with minus U plus V. So notice that 4 times LM gives me LR, vector LR. So therefore LM is parallel to LR, parallel to LR, since you can multiply one by a constant to get the other. Therefore L, M, and R all lie on the same straight line, meaning all these 3 points are collinear. And that's the end of our paper.